Hey, Scott, want to play?
Nobody turned their heads. We've got a little gift for you here.
The worst named Microsoft product ever.
What do you have for me?
Oh my gosh, I have so much to show you today.
I remember when I started at Visual Studio 2019, I was surprised how fast it started. It went right to the start window.
Now C# and .NET Core users can rejoice because...
High five. Loud chair high five. Rest well, old friend. Well, I hope we fix that in post.
Go for it.
Visual Studio 2019 for Mac has the same IntelliSense, code refactoring, syntax highlighting that you get on Windows now.
No phones.
I still remember the moment when I first started using Visual Studio in 2001 after coming from an Emacs and a Unix environment, getting IntelliSense for the first time. I mean, it felt magical.
Yeah.
I think that's really what we're doing again now with IntelliCode.
Literally time travel debugging. I'm moving forward and backward in
Exactly.
That's my normal thing.
You have it for TypeScript, JavaScript, Python, and Java.
Well, now you're just showing off. It's not, Saturday Night Live quality timing, but I think it's gonna be okay.
Please welcome Partner Program Manager Scott Hanselman.
Hi, friends. How are we doing? It's a little early for a developer, isn't it? Are there any real developers here? Because it's about 7 a.m. West Coast time, and I don't know how. We have got some wonderful folks and friends who are joining me on stage today, as well as some awesome demos. This is application development for everyone, and as I always like to say, everyone is welcome. This is the future, and it's a really great time to be a developer no matter what you are building. Every developer's got that potential to change the world. Every language, every person, new programmers and old, any language, operating system, whatever. So let's take a second and let's recap what's new and some of the cool announcements before we get into the real tech. So yesterday in Jason Zander's keynote, we announced Visual Studio Online. You can create a dev environment on demand, setting it up in minutes instead of hours. Some people show up at their company and it takes them months to get up to speed. It'd be nice to have a development environment that you could get in just minutes. And then Visual Studio Online, of course, works with the tools that you like, right? Whether that's Visual Studio Code, whether that's the Visual Studio IDE, or you can even use that browser-based editing experience that we saw with VS Online. And it lets you basically be productive from just about anywhere. The part that's amazing also is that Visual Studio Online has access to the full extension marketplace. So things like VS Live and IntelliCode just work, which is amazing. And we're pretty excited to see how you like this service, so make sure that you go and sign up today, start using it, and give us the feedback, and we'll make it even better. On the Azure side, DevSpaces Connect for AKS lets you go and develop and test individual spaces. We'll see a demonstration of this on your local workstation within the context of a larger application within a shared Kubernetes cluster. And then making container applications can be a little overwhelming. A lot of us haven't done container type development before. This makes it a lot easier to do and lets you focus on your microservice in the context of someone else's larger application. Azure Functions has got new language support, so we've got .NET Core 3, we've got Python 3.7, and there's also a new premium plan which gives you no cold start, basically keeping your Azure Functions warm all the time, which is cool. Azure Security Center has got vulnerability assessments on container images, and then App Service now has managed certificates, so you can get free SSL on your app service. And then for our Java friends, the Azure Spring Cloud, which is going to let you do your Java Spring Boot apps built and operated in partnership with Pivotal, which is pretty fantastic. As I'm saying, our goal at Microsoft is to give the developers any platform that makes you happy, your languages, your tools, everything that you need to make the next generation of apps. I really like that slide. But what I like the most of all the things So over the last several years, we've seen developers all over the globe building and deploying some amazing solutions. And we know that I like tacos. We know that I eat them when my wife lets me. And because she's not here, I've had them for breakfast, lunch, and dinner for the last 3 days. And that's okay. But I want you to really take a moment. I feel like I'm channeling Panos right now because I'm talking like when he talks about the service. Just take a moment. Think about this. I have the pleasure of realizing one of my biggest dreams. Pause for effect. Realizing and welcoming Chipotle at a keynote. And learning about how Azure and .NET is helping them achieve business success. Let's give a huge round of applause for the lead developer at the Chipotle online service, Mike Smith.
Good morning, Scott.
This is like the biggest thing since I met Janet Jackson, and I've never met Janet Jackson, so you are the biggest. I'm a little nervous to meet our friends at Chipotle, so hi. Hey. Sorry. Do you see my shirt?
I love it.
So Chipotle.com has an ordering service where you can go and order and deliver tacos and burritos to people. I understand that this is built in .NET.
Yes, we have for our ecosystem Vue.js running on our front end.
Okay.
And then the back end of our ordering platform is going to be all done in .NET Core, ASP.NET, Web APIs. And that services not only our website, but also all of our other clients, so native iOS and Android, and our Alexa app.
Oh, wow, okay. So then you've got an API in back end that is in Web API. You use it, and vendors use it, and whoever wants to use it, which is cool. And then on the back end, C# stuff, I know that you're a fan of C#. What are some of the features that you like about C#? There was Link.
Async 08. It is fantastic that the Microsoft people had some brilliance to go and reduce a bunch of boilerplate code for us. So now we've got one lines for async 08 instead of having to manage all of the nested callbacks and stuff.
Exactly, and that's the idea, that a bunch of boring code that has nothing to do with tacos just becomes async in 08, which is awesome.
Exactly.
And speaking of boring code and things that you don't like I know that originally there was a lot of SQL going on and a lot of talking to traditional databases, but you're doing something different now.
We are using Cosmos DB at this point. It is the next best thing to our carne asada tacos.
Yes, the carne asada tacos are very nice and certainly better than SQL.
Yes, loving it. Yeah.
So then you just throw documents at Cosmos DB and it's just handled for you and you don't think about it. You use the native SDK?
Yeah, the C# native SDK. We've reduced almost all of our queries. It's just very simple with the partitioning that we've set up. And the performance is just fantastic.
So you need this to scale. I assume that there's times when people want tacos and there's times when people don't want tacos. So the scale goes up and down and you have to think about that.
People want tacos all the time.
That's true. So you have infinite scale all the time?
Right.
All right. But you're running a lot of app services and there's a lot of configuration to manage. And I have like a small website. I manage my configuration with like environment variables. It can get a little tedious. How do you manage configuration?
We've started to look into the app configuration for Azure, and we put a POC together in just a handful of minutes, and the tools work nicely from spinning it up inside the IDE to automatically creating the app configuration in Azure. And we were able to have a conversation with all of the leads and make a decision on where we want to go.
So this is fun. So they're actually prototyping stuff. So there's things in Azure that they like. There's things in Azure that you're playing with, and you're doing proofs of concept.
Yep.
And you're able to spin those things up and enjoy them and decide whether or not you use them or not really quickly.
Yeah.
So not only is Mike here, but he has brought a version of the Chipotle website that isn't even out yet. And we're going to see their staging site. You going to show it to me?
Let's see it.
All right.
Got a fresh new look coming out this year.
You have to understand that this isn't for you. This is for me. And you are also here.
Spell Scott today.
So this is not what the site looks like now, but it will be what the site looks like soon.
Correct. I'm sure you've probably tried everything on the menu.
I have.
Well, let's order you something for today.
All right.
What are you feeling?
Tacos.
I mean, and then 3 tacos because...
Who orders 1 taco? I don't even know why that button exists.
This is not a meal for ants here.
No. We'll do flour, carne asada. Are you paying?
Well, I am signed in on my account here, so.
Double meat.
All right, all right.
No rice, no beans. Need more room for the meat.
That's right.
Pico de gallo, tomatillo verde, cheese, chips, because you're paying.
Of course.
2 chips.
So one for me?
For me for later.
Okay. Snack.
All right, cool. And let's add that to the bag. And then we're going to make this a preset so that you will be able to order me things from anywhere.
You know, just give me a call and we'll make it happen.
I'm just going to text you, and that's going to be great. Oh, let's hit it here. Let's try it. Between Scott 1, maybe. Maybe there's too many tacos that have been given to me in the past here. It is a staging server, so. Forgot the guac, see?
Yeah.
That was the error message. It was actually, if we check console.log, it would be like, no guac, throw exception. Nicely done, sir.
Yes.
All right. Okay, we'll go ahead and check out. It'll be here in an hour. That's cool. I'm actually going to be at Channel 9 in an hour. Can we have that delivered to Channel 9? Channel 9 stage, cool. And then you can do delivery or pickup.
Yeah, let's double check this delivery and make sure we've got this coming to Ignite.
Okay.
We don't want you to have to go drive and pick it up yourself.
Yeah, I can't go back to Portland.
No.
I would, but I can't. Okay, cool. And then let's tip them. I'm a generous tipper. Nice.
All right.
And then there's your credit card.
We'll throw this on the corporate account here.
It's all
Go ahead and
expenses.
submit this.
All right, cool. So this is going to be sent off. Now, right now, this is being sent into Cosmos, but I assume that there's telemetry and other things that you're looking at. What other Azure things are you using?
Yeah, we're using Event Hub to help scale our telemetry and providing the performance that we need.
Fantastic. And it looks like I've got lunch. Literally, we nailed it, actually, the exact number of minutes. So that's going to be showing up at noon.
Perfect.
Thank you, sir. Appreciate you.
Thank you, Scott.
All right. So now I've got lunch handled, so there's that. How fun is that? Chipotle is a really great example of a customer that's using .NET, Azure, and Visual Studio to provide speed and scale to have a really good experience for their customers. And of course, Azure, as I've said in the past, supports the tools and the languages and the apps that will make you happy. And over the last couple of years, we've seen some really amazing solutions that I want to get involved in. And let's take a little bit of a deeper look at what kinds of things. When I say your languages, what do I mean? Well, you can develop in your favorite language. We've got a commitment to open source and support for basically all languages and frameworks. You build the Azure that you want, and you deploy where you want to, and you build, debug, deploy, and manage apps with the platform of your choice. Those are the languages that we're going to use today, and I think that that's just text. That's not fun. Those are the mascots for those languages. And we were thinking, what could we build? You know, we build hotel apps and we build, you know, Northwind Bank and different things like that. Why don't we make something a little bit more fun? And I was watching my kids trying to solve an argument, and they were getting, his hand was in a fist, and I was like, no, use your words. And then he was like, rock, paper, scissors, shoot. And I was like, oh, okay, that's cool, you're allowed to do that. And I thought he was going like this, but it was, they were doing Rochambeau. And I said, well, rock, paper, scissors is a good game, but let's do it a little bit different. Why don't we do rock, paper, scissors, lizard, Spock, which is the advanced version of rock, paper, scissors. And this was actually, you may have seen this on a popular TV show, but it was in fact an internet game before, created by Sam Cass and Karen Bryla, and you can go and take a look at their site, and we're using it under Creative Commons. And this is a great game because it's way more complicated. Rock, paper, scissors is easy, right? Like paper covers rock, which is ridiculous because the rock would totally mess up paper. There's no scenario where paper is hurting rock at all. Paper is basically useless. But Spock vaporizes rock because he has a phaser, and then paper disproves Spock because apparently paper is like a physics paper by a PhD or something and proves that Spock doesn't exist. I'm explaining too much. Let me just show you what this actually looks like. So we went and we made a game. It's rock, paper, scissors in the cloud at scale. Oh, yes. So you go into the game, we pick .NET, Node, Python, Java, PHP. These are all the mascots of the PHP elephant or the Node.js rocket turtle. And I'm going to go and pick, we'll pick Node. I'll hit select. And then I can pick rock, paper, scissors. And then one of the microservices will be running in Node, or the microservice would be running in PHP or Java, is then going to battle me. And I'm going to go and do Spock, and I'll start the battle. Rock, paper, scissors, shoot. Paper, I lose. Paper disproves Spock, right? So some of it works and some of it doesn't work because we're still building the application. I've got some bugs. I've got some issues. So what we're going to do is we're going to talk about how we are building it and how we can make it better and make it work in the cloud for everybody. It's a super fun idea to go and have each of the bots be different. Let's look at what the architecture looks like. So here's the idea. We've got the whole thing running in the context of Kubernetes. Each bot is a different language. So these are microservices. And they're all talking through this game manager that we've got written in .NET. And then the Kubernetes API server manages all of these things. I wanted to show an example application like this because your applications will start looking like that. If you were making an app like Chipotle and it was like a microservices app, you might have a shopping cart and a user login and a session manager. You're going to have different responsibilities, and your teams are going to use different languages and different systems, and you want to be able to manage the entire experience. So while this might seem silly, it's actually an architecture that is representative of the kind of stuff that we're seeing. Large, scalable, flexible, hybrid apps that you can go and create. Now in this case, it is a multi-language application on AKS. Right now it's human versus bot. Theoretically, it could be multiplayer. The website on the front end is using Blazor, which is our web application framework that we are doing with C# and .NET Core 3.0 that we'll learn about later this week. And then any one of these players has a different strategy. So actually, let me switch back over here for a second and bring up this screen again. I'm going to switch to the code, and I want to show you here. We've got all these different services. So we've got a Java API and a PHP API and a Python API. So if we go and look at, like, for example, Java's got different strategies. So in this case, if it's seeing rock is about to come, it could do a fixed pick, or it could do a random pick. It could iterate. It could just go rock, paper, scissors, and then make a decision. So it's not super sophisticated. PHP controller has a predictor, and it has its own strategy. Each bot behaves differently, and you can potentially, if you wanted to, take this code, update it, change it, write your own strategy or your own bot to go and do that work. All of these things run within the context of AKS, and we're going to show you how we can even make it smarter as we move forward. Make sense? Let's go ahead and switch back to our diagram slide, and hopefully we'll get some cool things that will surprise you. Now, let's talk about the tools that we use to build this, and then get to some demos. So we're doing all of the work on GitHub, and everyone, of course, is spending their time on GitHub. This is where modern development happens. And I think that Microsoft is kind of becoming unique in the industry now because we're doing so much stuff in open source, and we're making tools for every developer. GitHub being one of them. You can innovate and collaborate with everyone. One of our friends from GitHub is going to come out later, told me that almost 80 or 90% of new application development includes open source. Very rarely does an app start new where there's not some open source involved, which is really interesting. So we're going to hear about potentially dealing with security vulnerabilities and being able to make that into a great experience. Because open source isn't just about the code, it's this interconnected web of communities, developers, and libraries around them. And in order to make people more productive, we're going to want to move people towards DevOps and move people towards a more collaborative and accelerated environment. Now, we used Visual Studio 2019 to develop this. We just released it in April. Feels like it was a little longer than that. And yesterday, we just came out with a preview of our next version of 16.4. Even little versions of Visual Studio are adding great new features. We've integrated the terminal into Visual Studio now. We'll see that demo in a little bit. That's in 16.4. We've got the amazing hot reload for mobile apps, which allows you to actually change your XAML and not restart your mobile app, and it actually shows the change immediately. That's coming soon. Container tools and Docker management directly inside of Visual Studio. Also, improving GitHub support in VS and improving live share. We've also got really cool things like historical debugging, moving forward and backwards in time while debugging, which is amazing. And then if you haven't tried it, live unit testing. Literally, as you're writing code, as soon as you hit Control-S, it's running your tests all the time live in the background. And if you haven't upgraded since April when you got 2019, you got to check out the improved Test Explorer, which has a way, way better experience and works a lot better for hundreds or thousands of tests, which is worth pointing out. And this is important. I run multiple versions of 2019 on my machine, so you can run them side by side. You can run the release one and the preview channel without worrying about them. So if you're already running the one that your company lets you run, why not go and install the preview one, run it side by side, try the things out in your production environment, and then you can always just keep using the other one. And then you use the Visual Studio installer, and you can keep those things updated and decide which versions you want and which features make you happy. Some people use Visual Studio Code, runs anywhere. It's that lightweight code-optimized editor. It runs on any operating system. It runs with any language. And the best part is that there are over 16,000 extensions to Visual Studio Code in the marketplace. They're super easy to write. And the exciting new feature that I like, and the one that we're going to see today, is remote development. So this is a set of extensions that lets you work with projects that aren't on your local file system. You can actually write your code, do your builds, and the stuff is elsewhere. So we've been there before, right? Where you've got a system set up, you don't want to mess anything up your current environment, but I might want to try a new language or something else. I can connect to that remote environment, but I still get the tools that I expect. So I'm going to show you VS Code in WSL, the Windows subsystem for Linux. So we'll actually be on a Windows machine, running a Windows app, but doing development within Linux on the same box, which is cool. Letting you do native Linux development on a Windows machine. Cool? Let's see what that looks like. All right. So here's a Windows machine. We'll go ahead and check this out. I'm going to do the first thing, which is what I always do, because this is how I roll, is I'm going to load up the terminal. Some people say, hey, where's the visual in Visual Studio? But I like to go both ways. I like a little terminal. I like a little UI. I like that the new Windows terminal lets me do things like control scroll, because I'm getting older and I need my fonts big. This thing is all open source. Right now I'm running PowerShell core, but I can go like this. And I can control my profiles.json, and I can go and put in whatever makes me happy there. All of that was written on our own, and then the Azure Cloud Shell is integrated in the terminal as well, so I can get a free container whenever I feel like it. If I go and open up settings, I can import other people's profiles, change fonts. Every individual tab can have its own style and its own look. So when I go like this, this is Ubuntu. That's Windows and PowerShell core, which, by the way, is open source, cross-platform, and runs on Linux. But in this case here, I'm on Windows. Here's Ubuntu. There's top. There's htop for the kids. I can go LSB release -A. You can see where I am, though. I'm on the C drive. What if I change directory over here? Now I'm in my Linux world, my Unix world, and in this case here I can go and do something like Explorer and run that. There we go. And there's my file system. I can go and I can run LL. I can go into rock, paper, scissors and see that. Oh, look, you see my cool, I'm on that branch. Let's go and say code dot. Now watch this. I'm running a Windows executable from within WSL. So I'm running Linux, but I ran Windows and it said, that's not a Linux thing, must be a Windows thing. It's a Windows thing, and it ran the Windows thing. And look in the lower left corner. We're connected to VS Code. VS Code split in half. It's running the Visual Studio Code headless server in Linux. And it's running VS Code client in Windows. So if I go in here and say Control-O, that's my local Linux file system. This is the Node version of our application, and this is looking at the pick strategy of that. I could go and bring up the new edge, and at this point, things are getting annoying because it's window management time. It's like, move this here, move that there. At this point, I'm not writing code, and that makes me sad. So let's talk about Power Toys. Power Toys are back. If you're super old like me and you remember that we released Power Toys for Windows in 1995, it is not 1995, but Power Toys are back. And what we're doing is we're pulling in different open source tools and incorporating them into a new Power Toys. And then certainly if you put enough enthusiasm and pressure behind it, maybe Power Toys will become features of Windows. But these are for prosumers. I'm going to hold down the Windows button. Look at that. That's one of the Power Toys, giving you all of the hotkeys that you might forget. But the one that I love is Fancy Zones, because it's fancy. I'm going to hold down Shift, and I'm going to start moving VS Code and my browser, and I've got a pre-set up developer environment. I'm even using hotkeys, Windows left, Windows right, and suddenly I can have a tiling window manager with zones that I laid out. So that's my development environment, just like that. Is that cool? Yeah. So let's do this. So I'm gonna hit a breakpoint. I'm gonna hit F5. We're gonna run our Node application. Where is this happening? Let's think about this. This is really cool. Oh, it hit a breakpoint. I just hit a breakpoint in VS Code on Windows connected to the Linux machine, which isn't a machine because it's my machine. WSL isn't firing up a big virtual machine where it's like, wait for the virtual machine to start. This is a tiny micro little machine that starts up with a little Linux kernel that we're actually shipping with WSL2. Windows will ship a Linux kernel with WSL2 next year. And on the right-hand side, you notice how it says localhost. With virtual machines, you got to think about stuff like that. Whose IP address is what? Who's talking to this? It's my computer. We actually punch a hole. So when I opened up port 3000 in Linux, I'm going to go and talk to it out in Windows world. So I'm going to hit F5, and there's my API for talking to our rock, paper, scissors application. I'm going to open this up and show you HTOP. So I'm running HTOP is Task Manager, kids, for Linux, for the young people. Look there, look at the top. It says VS Code Server. That's that Visual Studio Code server. So when I'm typing and doing IntelliSense or getting syntax highlighting and I say variable dot period and I get IntelliSense, who did the work? I don't even have Node installed on Windows. It's entirely in the Linux world, which is fantastic. All of that work is being done by the server, so it's a really, really nice experience to split those two things and do interactive debugging. You get to decide the platform that makes you happy. Isn't that cool? All right. It's happening! Working on this stuff for so long, it's so cool. Now, what can I do if I want to build and extend my app, and rather than using Node, let's go and create a bot in .NET, right? I like that I can build anything in .NET, and you know that with .NET Core and open source .NET, we've made significant investments over the years to really unify the ecosystem. There's a lot of people in the audience who might be Windows Forms developers or web form developers. Maybe you've been doing WPF. Maybe you've been doing .NET for 15 or 20 years, but you've only made one kind of app. Or maybe you just learned .NET in the last year or two. You made a Hello World console app, but you're not really sure what you can build. You can build anything. You can build games that run on Xbox or any platform. You can run IoT devices, and we're going to see a cool demo of that. You can do AI and machine learning with .NET. If you are any one of these developers and you know .NET, You can be any one of those other developers. I became an Android developer yesterday when I made my Android application, even though I'm most comfortable in ASP.NET. And it felt very comfortable because it's where I'm already spending time. It's in Visual Studio, building anything. Now, .NET Core 3.1 includes Windows desktop support. There's a lot of Windows desktop applications out there that require a specific version of .NET on their machines. And you might have someone say, I don't want you to upgrade .NET because we have an expense application from 10 years ago and we don't want to piss it off. With .NET Core, you can actually go and have flexible side-by-side deployment where your app can actually have its own build of .NET. You can publish it by itself, even as a single exe in preview, and then have just myapp.exe, and it won't hurt anything. It's going to be really great. So you can deploy apps on machines that don't have .NET installed with .NET Core 3. You've got that side-by-side support, those self-contained executables, WPF and Windows Form support, and then of course that full stack web development support with ASP.NET, web APIs, the MVC model, the Razor model, the new Blazor stuff. It's super cool, making beautiful and responsive single-page applications without having to write any JavaScript. Now, I'm writing a microservices container app like the cool kids, so I want to make sure that I'm doing the right thing. So I'm going to ask my friend Leslie Richardson to come out here and show me how to make a microservices application using .NET and C#. Leslie.
Thanks.
Hey.
Hi. Ooh. Thanks for letting me be taller than you.
No, my pleasure.
Cool. So today I want to talk about the microservices that primarily make up this application. So we've got three main ones. We've got .web, model uploader.web, and game.api, which is the one I want to focus on.
Okay.
So game.api is actually a gRPC service that's responsible for establishing communication between the API and all the other game mechanics and services, such as player movements, challengers, that sort of thing. So one of the things we've been working with Google, the original creators of gRPC, on is adding support for proto files. And this is a file that will allow us to define gRPC-based APIs. So we've already done some definitions here. In particular, we've defined a service called Game Manager, which consists of two methods, one being get challengers and the other being do play.
And that's not C#, right? That's a proto thing. That's a gRPC thing.
Correct. And the best part about gRPC is that we can actually, from this proto file, go ahead and generate some client or server-side code for whatever language that we want. So in this case, we're doing it for .NET, but we could also do it for Java, Go, JavaScript, Node, all that jazz. So yeah, here's the reference to that proto file in the CS project. And again, I'm generating some server-side code that's going to automatically create those connection channels that I don't need to worry about. So no sweat. And once those get generated and stored in an object directory, I can just inherit from them. In this case, I've done that in this Game Manager service class. So you can see I'm inheriting from GameManager.GameManagerBase.
Okay, and that was generated from that proto stuff.
Yep.
Cool.
No sweat, don't need to worry about it. And scroll down, and looks like there was a to-do that has been left for me. So I need to complete this for each loop by, in this case, taking this result variable that's going to be returned and then setting it to all of the challenger information.
Okay, these are the people that we're going to fight when we do rock, paper, scissors.
Very important. It's not a game without actual challengers.
Got it?
Yep. So the problem is, this is normally where IntelliCode can start to work its magic and provide me suggestions based off of what I start to write. But because the result variable and its related classes and functions are specific to this particular repository and they're not public, it may not give me the best informed suggestions.
So let me see if I understand. There's Intellisense when I type a variable and I hit dot, and that gives you like an alphabetical list of stuff. And IntelliCode takes all of the open source applications that are on GitHub and builds an AI model that describes it. But this isn't open source yet.
Right, yeah, because it's not public. But luckily, our good friend and colleague Allison has gone ahead and taken an IntelliCode model, trained it on this specific repository so that I can get suggestions that are unique to what I'm writing in this code base.
Oh, okay, so she's associated with this repository, and since we have access, we now have the IntelliCode model for both all open source and the rock, paper, scissors app.
Yes.
Cool.
Yeah, so I can start typing result. A dot? Oh,
And see,
challenges.
so the star is IntelliCode.
Yes, and that's exactly what I want, actually. I'm going to add another dot.
Now, you're just typing dot and hitting tab. Is that really programming, though?
Yeah, I get a lot of money to just type a dot every day, and
Well, as long as you're paid by the line of code and not by the hour.
Exactly, that's really what matters. So from there, I'm adding challenger, and then.
Now that's interesting. So in this case here, before you were doing, method dot, and then now you're doing a parameter, and it knows about challenger, which is an object type, actually marked as a var, and it's suggesting the right thing there as well. So it's really contextual.
Yeah, that's the best part about it. So no guessing games here. And info. And I did so much work to write that. That was
Coding is exhausting.
so tedious.
Okay, cool.
I have to do every day. So now that I have that, now I would like to take a look at some of the log information just to make sure that my app is running smoothly. So in the doPlay method, I've added some Kubernetes logs, one that's referring to what the player chooses as a move, the second being what the challenger has chosen as a move, and then the third being the result of the match.
So we've got logger.log information using dependency injection in ASP.NET, and that's going to show out into Kubernetes, because this is a Kubernetes app. You need to run all of this in the context of Kubernetes.
Yes.
Okay, cool.
All right, so from there, this would be when I have to turn on the terminal, which I know you like.
I love the terminal. Are you going to open the terminal?
I would, but did you know that the terminal's actually already in Visual Studio?
I did know that.
Yeah, so in a recent update, we've now incorporated the terminal within VS.
And you're actually sharing a lot of code in there with the Windows terminal that we saw, so you can use the terminal that makes you smile.
Exactly. Yep, so I'm going to use PowerShell and use the same Kubernetes commands that I've come to know and love. And
you type really fast.
thank you. Shout out to elementary school for all the Mavis Beacon classes I had to do.
Where is Mavis? I hope she's okay.
I know, yeah.
Okay.
All right, so I'm going to copy that address, and we're going to go into Edge.
So this is your own personal cluster right here before we go and put that into production.
Yes. Yep. And here we are at the game. I like to play this game, so I'll add myself as a player.
Okay.
And now we're at the opponent. So choose your opponent.
Python.
All right.
Snakes.
Sounds good to me.
It's okay. You can own that.
I was proud of that one.
It was good.
Okay, and I'm going to turn on all the logs so that this particular pod, that
Right, so you're
game API.
getting the name of that particular pod that you're running in right there, and then it looks like you're getting kubectl logs.
Mm-hmm.
Okay, cool.
All right, so we've chosen Python. And I'm going to choose lizard. There's a lot of lizards in Florida, so I think it's fitting.
Yeah, they're freaking everywhere. There's
know.
like 3 in my room.
Good grief.
Okay, rock, paper, scissors, shoot. Boop, boop. Lizard. I think.
No!
Scissors decapitates lizard.
Shoot, I'm really bad at this game, but.
Yeah, that's pretty aggressive.
Yep, but luckily for us, we did win the log information as expected. So, as I mentioned before, I got one log saying what I chose, another seeing what the challenger chose, and then finally what the result of the match was.
Very cool.
All within the Windows terminal.
So
VS terminal.
you're doing all your work in Visual Studio. You've got the Windows terminal right there. You're talking to Kubernetes. You've got gRPC, so you're talking across to different languages. In this case, we're fighting with Python, and our application is looking better. Thank you for doing that.
Thank you.
All right, good to see you. I dig it, I dig it. My app is starting to get interesting with all these different languages that I want to take advantage of as I try to build this app in the cloud. Now there's a lot of cool stuff going on in the Azure space, and there's an immense amount of potential for what you want to do to scale your apps. Azure is kind of that world computer, and it's global. And if you haven't looked at Azure in a few months, you may be surprised to see what we've got these days. There's a lot going on. Now, there's a lot of diagrams out there with the boxes and lines that describe all this stuff. And I could have put together a diagram that would be like, Azure, and it would have all these different things that we have. There's like 200 products and services. But this is a really nice high-level map. I'm trying to make each of these slides such that you could actually take a photograph of it and find a little bit of value there. This expresses the different things that can run on the edge, the different things that can be expressed in a serverless way in the middle there, so whether they be scaling out the web, scaling out your mobile apps, or your Internet of Things. And then at the bottom, your low-level infrastructure, whether that be compute, networking, storage, or whatever. We've got all the DevOps tools, all the dev tools, and all the innovation to really get that core infrastructure. So if there's something that you need, we probably have it in one of these categories. So a translation is that gives you the scope of what Azure as a platform can do. And what's nice about it is that it's all just a cafeteria plan. You just pick the one that makes you happy. If you like it, use it. If you don't, that's cool too. Whatever here looks like it could make your application better, give it a try. Now, in the past, I did a lot of work in virtual machines, and when I moved to the cloud, I did it in a fairly naive way. And by naive, I mean we had a virtual machine at work, and we moved it to the cloud, right? And in that case, the cloud is just a euphemism for other people's computers, right? The cloud is just hosting in that way. That's fine. That's how you lift and shift. Naive is not an insult, it's just the step 0 of your process to the cloud. But as you start moving to what are called cloud native apps, you're going to have applications that are more broken apart. You're going to apply the single responsibility principle, and you're going to want to try to accelerate your development without compromising your quality. So I've got this really great diagram that we put together to give you a sense of what containerized cloud-native app development looks like. I don't like buzzwords. So when someone says cloud-native, what does that mean? That means a systems architecture that was invented when we had an understanding of the cloud and what the cloud does and can work for us with. So if we look here on the left-hand side, it says inner loop. You might hear that term, the developer's inner loop. Remember how before I was moving windows around? That's not fun. So I made it fun. I used fancy zones. If you find that you're spending more time setting up your app to run than you are writing code in your app, that's not fun. So you want that loop, that debug and test loop, to be as fast as possible. So if you can make a change to your code, hit save, get immediately something like live unit tests, if you can immediately fire up a new container, if you can immediately get a sense of whether it worked or not, you can fail fast and fail often. Then when you get it right, you check it into GitHub, and you want your folks on your team to be able to give you a review, to give you a sense of whether or not it was a good idea or not. You want all the bots. Anything that you can do to automate your job is better. Angie Jones always says, automate all the things. Automation is your friend. So if you do something twice, stop and automate the third time. We want to try to do that as much as we possibly can. So in this case, we're going to check it into the GitHub repository. We're going to go and call it a GitHub Action. And that action can automate things like the relationship with my team and that application development lifecycle. It can then put that into the Azure Container Registry, generate an image, then that gets put into the production cluster, and then I can go and monitor it. So you can have a full CI/CD, continuous integration, continuous deployment pipeline to your clusters with these automated routine tasks. You could have canary development, canary in the coal mine, dev, test, staging, production in just a few clicks. And if any time something fails, you can get real nice traceability. This can be a little overwhelming and a little confusing, so I wanted to bring out Jessica Dean on stage to help me understand how she takes advantage of dev spaces, Kubernetes, and GitHub.
Hi, Scott.
Hey, how's it going?
It's going well. How's it going with you?
Good.
Hi, friends.
All right.
So what's going on here?
Well, so listen, we've got rock, paper, scissors. Mm-hmm. It is in Kubernetes, and I'm starting to get a sense of how these things work, right? We've got all these little microservices. There's a lot. There's like, how many languages do we got now?
There's actually 7 different microservices.
Okay, 7 microservices across 5 languages.
I have some bad news, actually. Right before I came out on stage, I was just informed somebody made a change. Of course, we always do that in the middle of the keynote.
Right before the talk.
Great idea.
Yeah.
And actually now we have a bug in just one of our microservices. It happens to be in our Node microservice.
Okay.
So I know that you actually showed us how we could debug locally, right, earlier in the demo, and how we can kind of play with maybe more of an isolated scenario.
Yeah, I was literally running just the one thing, and I only saw the JSON. I never actually ran the app locally, because it was a hassle. I didn't want to set the app up on my machine.
Of course, and here's the problem, is actually to kind of see the problem, we need to see all those other microservices. We need the other 6 microservices.
Right.
So the problem is that Node is not properly displaying the selection. We can't see rock, paper, scissors, lizard, Spock. So I want to show you how you can troubleshoot this kind of issue with something called Azure Dev Spaces, even in a microservice, complicated kind of world.
Okay.
I'm going to use the Azure Dev Spaces extension. It's available right from the Visual Studio Code marketplace, and it's going to enable rapid Kubernetes development. So the cool thing is all I have to do once I have that set up is start working as a developer, as I normally would. I'll set a breakpoint on my return call, which is part of my pick function, which is going to give me a choice list array.
All right.
And then I simply hit Control-Shift-P to bring up my command palette. That might be Command-Shift-P if you're using a Mac. And I'm going to choose to redirect the existing Kubernetes service, that broken node service, over to the code I currently have on my machine.
Okay, so hang on. There's 7 different services. One of them's broken. The ones that are not broken, you're not going to worry about. You're just redirecting the one.
Just redirecting the code just for node. So I'll go ahead and click that. And then from there, I'm going to choose a mode. And the mode I want is to actually create an isolated copy of that broken service, what we call a child dev space.
Okay.
Not because I'm a child, but because I really want just a sandbox to sit there and kind of play around in and not worry about breaking things.
Cool.
So I'll choose the one with my name on it, right? And then all I have to do from there is enter the port of the application. It's classic Node, so port 3000, nothing to worry about. And then Azure Dev Spaces, and thanks to something called Azure Dev Spaces Connect, which is now in public preview, we can sit there and not have to worry about, as a developer, if it's a container, if it's Helm, if it's Kubernetes, environment variables. Visual Studio Code and Dev Spaces set all of that up for me. In fact, you can see all the exported environment variables and everything.
So it looked at our environment and then did what it needed to do locally to make that one microservice come down.
It handled everything. So now I'm going to clear the terminal. I like working with a clear terminal. We've set our breakpoint, and I'm just going to go over to debugger and start my debugger. Now this is no different than how I would normally interact with debugging, right? And then what's even cool is you can see right down here, I'm connected to that dev space on the right port that I need.
Okay.
So I can come back over to the application, or actually, before I do that, I can click Dev Spaces. I don't even have to go back over to Edge. Right from Visual Studio Code, I can choose to go to the web. And you'll notice that right here, if we kind of zoom in here, I'm actually using a subdomain of my fully qualified domain name.
Okay, you have your own personal dev space.
That's that sandbox.
But this isn't localhost 3000, that's the app.
Correct, because this is actually a dev space that's living in a Kubernetes cluster, but it's a private preview URL where I can troubleshoot it.
But then your node is local.
Exactly, so I'm just routing that traffic. Remember, I'm just routing the traffic over here. So the second I start the game, Visual Studio Code is now flashing because I've hit that breakpoint. And what's cool is thanks to Intellisense, I can actually zoom in. I can hover over here. Let's get a little bit higher. And you can see that the problem right off the bat is I misspelled paper. I clearly don't know how to spell.
It's the hottest new.com. You just register that with paper without the E, and it's going to be like $1 billion valuation.
I've just given 2,600 people access to a new startup. I should have copyrighted that.
Should have.
So now I'm going to do what every great developer does to solve this. I'm going to use find and replace. What could possibly go wrong, right?
Maybe a regular expression while you're at it, right? I mean, if we're living on the edge.
And at least now I can at least see side by side that, okay, it looks like I've spelled properly.
Sure.
So I'll go ahead and say, yes, I would like to confirm that I want to replace
What could go wrong?
What could go wrong? I'm going to remove my breakpoint. I'm going to go ahead and refresh the debugger.
Yeah.
I can now go back over to Edge, and we're going to restart this challenge battle, okay? So we're going to test to make sure that this fixed work. So I can click on scissors again. I'll start the battle. And in theory, if this actually worked, Node should now show paper, which it does.
Sweet.
And on top of that, I win, so that's awesome. But now, as confident as I am, how do I give you on my team and everyone else the same level of confidence?
I mean, I could review the code, but I'm not really good at
Who has time for that?
really
You
good
have
at that.
tacos to eat, okay? So I'm going to commit my fixed spelling. This way, I also want to make sure that no one knows I don't know how to spell, right?
Yeah.
So I'm going to go ahead and push. And you might have noticed that I've actually been using my own branch the entire time, right? I'm not working off of master. That could be dangerous.
Okay.
So as a result, I can actually go over and open a pull request. And this is where it gets really cool. So I'm going to refresh the page. You can see I just made a push about 20 seconds ago.
Cool.
I'm going to go ahead and say pull request. We're going to make an assumption that I went ahead and filled out all of this criteria.
Yeah, we all fill that part out all the time.
Everyone always does that. Now, the second I hit create pull request, there's actually something else going on in the background here. We have GitHub Actions and a GitHub Actions PR workflow that's set up to run a series of tasks. Everything the Azure Dev Spaces extension had to do, everything that was happening in Visual Studio Code and Kubernetes and Helm charts, all of that is going to be taken care of by this PR workflow automatically without any interaction. It'll actually take a few minutes to fully run, so I have a completed version of that action right over here. You can see all the different tasks that are happening. Things like create secrets and install PR namespaces and all these things that truly as a developer I don't care about.
Right, you just checked in the fix and you want validation of the fix.
Exactly, and this just really empowers me to kind of focus on the business logic. But now I want the rest of my team to have that same confidence, the same confirmation that I could spell. So one of the last things this pipeline does, or this workflow does, is it actually participates in the PR conversation. And it does that by adding a comment to the PR itself, and you'll notice that right here, we get a private version with a similar, just like what I had in Visual Studio Code in my preview URL, a subdomain where we can now go view this. So this means I have confidence, you have confidence, Ops has confidence. It's like Oprah over here. Everyone gets confidence.
You get confidence, you get confidence.
Even those who traditionally were unable to participate in the review process, designers, PMs, those who don't write code, with Azure Dev Spaces and GitHub Actions, we all can get the same level of confidence.
Freaking awesome.
It's pretty impressive.
You're a star.
Thank you very much. One more thing I need from you.
Yes, sir.
I didn't get to work out today, so I'm gonna take this and add some value to my gym.
There you go. She didn't do her CrossFit this morning, so she needed to take that back. Whew. I think that's really cool. So all of this being made possible with the power of open source to make us create these innovative applications. And to build this app, of course, I've been collaborating with my friends here, and they've been collaborating with all these other developers that are out there sharing code as open source. As we know that these developer communities live in GitHub, but a lot of us are enterprise developers. Open source is fun, but is GitHub really the enterprise place to put your source code? You want to have that sense of security and that things are going to be okay. And with open source moving so fast, things break, things are insecure. How do we make sure that people are safe and that developers get to focus on what they're focusing on, that ops gets to focus on what they're focusing on, and we set people up for success from a security perspective? It's important to make sure that you've improved your security posture. So I'm going to ask Brian Cross from GitHub to share with me how GitHub can help me secure these open source applications. Sir.
Hey, how's it going, Scott?
How are you, sir?
Hi, everyone. So GitHub has been the home of open source since we started over 10 years ago. And in that time, open source has really become foundational to the entire software industry, to the point now that really pretty much every project everywhere contains open source. And in fact, in enterprise applications, these applications can be as much as 50, 75% or more open source. And of course, this is great for an enterprise because it means that they're benefiting from the work of thousands or potentially tens of thousands of developers when we import all this open source code into our environment. But with great power, of course, comes potential danger, right? So we don't necessarily know whether all of this stuff that we're importing is secure. And beyond that, as a developer, if I just import a single module, I may end up importing thousands of additional modules that I have no idea about when I actually go to build this software project. So in order for open source to remain something that enterprises can consume securely and responsibly, GitHub had to step up to make the situation more secure. So we've done that in a couple of ways. So the first way we've done this is we've helped to protect developers from themselves. I always like to ask this question. Don't always get an honest response. Has anybody ever committed a token, password, or other secret to a public repo? So like 3 people raised their hand.
There's a couple of hands that have gone up, but they're very small because nobody wants to be on
Nobody
TV.
wants to admit it. I've done it. The only thing that was threatened when I did it was my personal bank account. But if I'm working inside of an enterprise, say a bank or something like that, that's an existential threat to my corporation if I commit the key to our cloud infrastructure, right? So we introduced token scanning a little over a year ago, and what we're going to do is match tokens for a wide variety of popular cloud providers, service providers, and others. We're not only going to detect that that token was committed, we're going to reach out to the service provider, we're going to invalidate that token almost instantaneously before we even let you know. So it's still going to be embarrassing, but it shouldn't be an existential threat to your enterprise. So by the way, like 4 people admitted that this has happened to them. We've trapped over 1 billion of these tokens in the last year and a half. So, you know, just saying.
But we're not going to name and shame.
We're not going to name and shame. It does happen. So the next thing that we need to do is we need to make sure that the open source that we are bringing into our organization is secure. It might be easier to just show you how we actually do this.
To the demos.
To the demo machine. All right, so let's say I'm a developer and I'm working on our application. I'm a Node developer in this case, so I'm working on the Node microservice, and I want to bring in the packages that I like to work with. So I've got a pull request here, and I'm bringing in some packages that I want to use. I'm going to go ahead and merge that pull request, and within seconds, GitHub is going to scan my dependencies and all of the dependencies of those dependencies, and let me know if any of those have known security vulnerabilities. And then it's going to tell me in a way that nobody can deny or say they didn't see that these vulnerabilities exist. So I can click on the View Security Alerts button, and then I can click on either of the alerts that I see and learn more about them, how to fix them, and even the history of the vulnerabilities in this particular module. And while I'm learning and edifying myself with all of this information, behind the scenes, GitHub is actually creating the pull requests that are going to do the needful to fix and remediate these security vulnerabilities. So in less time than it's taken me to tell you about it, GitHub has detected vulnerabilities in our dependencies, created the pull requests to fix them, and done pretty much everything that we can do to make it easy to do the right thing.
How would we have even done this before? Someone would just tell you, or you would just wait until your site was hacked and there was someone in your living room?
So that's a great point. And in fact, the workflow around creating vulnerability announcements, spreading that information, making it easier for developers to know that these things exist, all of that was very murky and vague. So in addition to these investments in the front-end UI, GitHub is actually working to bring those security workflows to a new home on GitHub. So moving forward, the same way that we go to GitHub for the latest and greatest open source, we'll also be going to GitHub for these security workflows and using it as a centralized point of focus for security awareness.
Wow.
Pretty cool. All right, so let's switch now to the complete other end of the software development lifecycle and take a little bit deeper dive into GitHub Actions. So Jessica showed us how they're triggered on a build to do the CI and CD and actually deploy your application. We're going to just take a little bit closer look. So workflows in GitHub live in the workflows directory, as you might imagine. Let's drill down and take a look at the Node version of this. And we'll just talk about how they're triggered for a second. So we've got this trigger clause here, and then one or more events. So right now, this particular workflow is triggered on the push event, but in fact, workflows can be triggered by almost any of the 100 or so events that GitHub supports. So you can use them for anything, not just CI/CD. But in this case, because this is a node-specific workflow, we only want to run it if the files that are being modified in a commit fall inside the scope of this node service, right? We wouldn't want to run a Java or a PHP build against a commit that's mostly JavaScript. And then lastly, we can further refine when these workflows happen by specifying one or more branches. And obviously, this is important. You might want to run your continuous integration builds all the time, but you certainly don't want to deploy unless you're pushing to a production branch. All right, so we're going to go ahead and kick this off the same way that Jessica did earlier. I've got a trivial change to a file. I'm going to go ahead and commit those changes. And then when I flip over to the Actions tab, give it a little refresh, and select my workflow, I should see that it's running. It probably hasn't queued up yet. That's all right. Sometimes it takes a second. But we'll drill down and look at the logs here. So if you're familiar with Azure DevOps pipelines, then you've probably seen this before. And that's because we built Actions on the foundation of Azure pipelines. So rather than start from scratch, we're building from that solid foundation. All right. So let's go back in and learn a little bit more about actions. So actions are comprised of jobs, jobs are comprised of steps, and then the steps are where the actual actions are. So you can use one of our built-in runners. You can run on Linux, Windows, and or Mac OS. And I just want to point out that in fact you can run on all of those at the same time using something that we call a matrix build. So what I've done here is I'm asking this action to run on this matrix with all 3 operating systems and 2 versions of Node. So this is a 3x2 matrix. That means I'll be able to fan out. I'm actually going to run 6 CI jobs, and then I'll fan back in and run the rest of my workflow. So you can cover all your test cases with a single workflow. But really the coolest thing, in my opinion, about GitHub Actions and workflows, we see happening right here. So we are calling out to this action the same way that we call out to a function in code, and we're even passing it arguments, in this case, secrets from our secret store.
This looks like a path or something here.
That's exactly what it is, Scott. It's a path to a repository, and here's the repository. In this case, it's a directory in the repo. So we've been talking about workflows. You probably thought I was going to talk about GitHub Actions at some point. This is a GitHub Action, and it's nothing more than a GitHub repository with an interface definition file, which is this action.yaml file. And all that does is define the inputs, those arguments that we just saw, and potentially outputs as well. So that's what an action is. And what this means is that inside of an enterprise or an organization, you guys can now write actions that your development team can then reuse across the entire organization. And in fact, this is really where the power of actions lays. So Microsoft has already created almost 24 of these actions in the Azure organization on GitHub. And even though we're only going to GA these on November 13th, there are already almost 1,200 actions that have been put into the GitHub marketplace by the larger user community. And in fact, it is the power of that interconnected community on GitHub that's going to do the same thing with actions that they did with open source. So we can look forward pretty rapidly after GA to an explosion of creativity in actions.
Cool. Thank you, sir.
Great. Thanks, Scott. Appreciate it.
So just absorb that for a second. So Jessica makes a change, checks it in, she gets a private space, all of that powered by Azure and Kubernetes and Actions. A security bug comes in, the bot gives you a pull request, the actions validate the request, run it against n+1 number of machines, in his case 6, it could be dozens, runs all of your tests. Your software development lifecycle can be as sophisticated or as smart as you want it to be, which is pretty cool. Now, my bots have not been very smart. Some of them were hard-coded to return paper, because I want to win. Some of them do a random thing, but I wanted to figure out how I could make rock, paper, scissors AI edition. Because why not apply the power of 1 million computers if you can't win at rock, paper, scissors, right? So my app is secure, but I don't know anything about AI. I mean, I can say it. I mean, it's on my LinkedIn, but it's a lie. I kind of get what's going on here. I want to basically have a rock, paper, scissors system that is smart enough to notice that I could beat anybody. And I wanted to bring Seth Juarez out, who's going to help me make AI and machine learning possible. How are you, sir?
How's it going, my friend? How's everybody doing today? Good? Well, it turns out that many people don't know this, but machine learning is just a lazy way of programming. And I'll tell you why. As you know, Dr. Internet, otherwise known as Wikipedia, has told us that machine learning is basically compiling data into algorithms, because there's certain things you just don't want to code. And this is what we're going to do today. And so what we've done is we watched you while you were playing with your consent, because we believe in ethical AI. And we have found that there is a pattern that you follow when you play.
Nonsense. I'm random.
It's true. And it turns out, like we said, machine learning is converting patterns into algorithms. This is what we found, Scott.
Oh, Lord.
Yes, we were watching you with your consent, and we took note of everything that you were doing. And it turns out that if we just choose rock whenever you play, we win 40% of the time. But we can be even smarter, because it turns out that any time that you play rock, you play paper right afterwards. So we're using that, and then we're going to be even smarter, and we went to the next level. When you play scissors, lizard, you always play Spock. So basically, if we keep track of what you've been doing in the session, we can actually predict what you're going to do and choose appropriately.
Oh, no.
Can I show you how we did this?
Yeah.
All right, so here we are with his consent, okay? So here we are. What I've done is I've basically written a little sample code, because I don't know any Kubernetes thing. Is that what it's called?
Yeah, that's what it is. It's new.
Okay, so basically you can see here, we have the sequence of things that you've done.
Right.
We've kept track of everything you've done. I said 40%, but it's 4 out of 11. It's a little rounding error.
All right.
Sorry about that. But notice here that every time you choose paper, you're always going to choose scissors. And then we went even further. Lizard, rock, you always choose Spock. So basically, this
I have a tell.
Is our machine learning model. Yeah, people think it's like there's like a magic unicorn in there or rainbows. While some models do have that, not the ones in computers, at least.
Okay.
So you can see that this is an actual model that we've done, and we just saved this into Cosmos DB. And so if you log in with Twitter, we keep track of the things that you throw, and then we just look at this matrix and look it up, and that's what we do. So what we decided to make it a little even more cleverer, which is an actual word. And what I've done is I've gone ahead and built this thing, because it turns out that what we want to do is we want to be able to actually have people with a camera throw a sign.
Ooh.
Did you see that?
Yeah.
Everyone saw that. But the thing is, remember, we actually needed data for it to work.
Right.
Because if we had no data, we didn't know what to predict.
Right.
Same with this. So we have to actually collect some data or some pictures. So I'm going to go ahead and collect some paper pictures. And I wrote this little app to submit this, and I'm gonna go ahead and hit submit, and I have written a Python Azure function that's running locally, eventually I'm gonna put up in the cloud, that takes these images and pushes them, you're never gonna guess where to.
The cloud?
Yes. How did you know, man?
Just
you're like giving away all my stuff.
Just spitballing.
It turns out that we're throwing it to custom vision that will build your own AI model with these images, and the pictures that you see, they're right there. Now here comes the hard part, because it's time to actually train the model.
I don't have a PhD in machine learning.
Okay, I did it. So that was it. Right? Isn't that cool? You basically give it the pictures, you give it the tags, and it trains the model. And you're probably wondering, well, does that model look anything like the other one? It turns out that it's a little different, but it's a similar idea. Notice that this actually gave you the template from where you could execute what to predict. This is the convolutional neural network that we build in custom vision. I had to throw that out because
you just like casually said convolutional neural network like it was nothing.
Data scientists get paid extra, and we have to say words like that. But notice that it's the same kind of thing. We're basically taking an image, we're passing it through a thing, and then it tells us what it is. Now, here's the cool thing about this particular thing. Notice that my model from before was a little bit better. We actually allow you in custom vision to export these things to your machine. So this one, look at this.
Ooh, I see .js.
I'm going to get in there so everyone gets the emphasis here. Hold on, I'm going to change to blue for emphasis.
So wait a second, is that .js right there?
Yes, that is .js. I can literally just download the model.
Okay.
I've already downloaded one, so it's already there. But basically, you can download this model and execute it on the client side. And you think,
what do you say on the client side?
In a JavaScript on the browser, using WebGL, using TensorFlow. But many of you may be thinking, I don't know how to use TensorFlow.js. That's okay.
Neither do you.
No, I don't. You're not supposed to tell me. Turns out that the fine folks of Custom Vision have released, and I'm happy to announce, an NPM package that you can download and use yourself on the client side. And look at it. This is what you do to import it. To actually load it up, you're not going to believe it's obviously really hard to do. So let me go here. This is how you load the model. And you're probably wondering, where does this file come from? It comes from that zip file that you downloaded. How do you use it? It's really hard. I'm going to show you again here on line 136. This is how you use it.
Yeah.
And you're wondering, where's the picture coming from? It can be a canvas element. It can be an image tag. It's craziness.
Well, it's pick right there on line 131. So my LinkedIn is true.
Yeah, it's true. You are now officially a data scientist. And now the cool thing about our particular application is that if we go and Control-Tab over, we have a way to actually upload the file. I've already uploaded it. It takes about a minute to refresh, and you told me I had to explain all of machine learning in 6 minutes. Rude. So I'm going to go ahead and close this one and go back to the original one, and we're going to use the webcam. We're going to turn it on, and let's see.
Deuces.
It works. Hold on. It's got to turn on. Give it a second. Now, here's the thing that's important. This model says that it has 95% accuracy, but it's 95% accuracy on the data we gave it. You got to remember that. Because I didn't have a lot of time to train it. But, oh, did it work?
Yeah, it worked.
Oh, I explained why it didn't work.
I was just making faces.
Oh, my goodness.
No, I was messing with it. It worked fine.
Oh. Well, dang, I'm trying to tell you to be responsible with AI, and you're
I was like, maybe it's not possible. Like, oh, it's that good.
So here's the thing.
It's worked twice now.
To summarize, we built a simple model, one that you could understand in your head. We built a separate model that's a little bit more complicated with the same idea using custom vision, a new NPM package you can download. This is AI. It's simple. You should use it. Thank you very much for your time.
Rock, paper, scissors in the cloud. I didn't have to ask permission or anybody. We did it without asking, and the bosses don't even know that we're doing this. It's so wonderful. You would not believe the stuff that they let me get away with at this company. Take a screenshot of that right there. That's explaining now how we've taken that Kubernetes cluster and now added custom vision to it. So we've got AI at two places, on the gaming place to defeat me, and then that's one model, and then separately on the webcam side, which is super awesome, because and I have no friends and I can play rock, paper, scissors by myself with the cloud. And it only took a cast of thousands and 7 microservices to do it. It's pretty good. So I love that the application is running in multiple languages. It's using AKS. It's now secure thanks to GitHub and Azure integration, and it's now intelligent. So I made this wonderful game that runs on a website, but I really want things to work anywhere. I want stuff on any device. Remember when we were talking about how with .NET you can build things that run anywhere? With the language that makes you happy, you can make devices big and small. I really like the Internet of Things. And I really like that slide animation. I'm going to do that again. Whoosh. There are thousands of capabilities that we've launched in the past year, and there are thousands of supported IoT devices. There's lots of great devices you can go check out on the expo floor, but I wanted to showcase one of the smaller folks that are doing some amazing stuff. And what I've got here is really exciting, because I, as a .NET developer, really love this. And to tell you how much I appreciate this and I love it, I'm actually going to take the screen protector off, which I don't do for anybody, because I want it to look beautiful. This is from Wilderness Labs. It's the Meadow Microcontroller. This is not a microprocessor. This is not a Raspberry Pi. This is not running a full operating system. It is a microcontroller, like the many billions of tiny microcontrollers out there, and it's playing rock, paper, scissors, lizard, Spock on a battery, and it's portable, and I'm going to wear it on a lanyard and play rock, paper, scissors as I wander around today, because that makes me happy. I've actually got a little screen here from Adafruit. I made a little 3D printed case, and our friends at Wilderness Labs, they had a great Kickstarter, and the Meadow Microcontroller runs .NET Standard. I don't know how to do tiny devices, and I did this wiring from a picture, because that's how I roll. I did solder this part though, and I felt pretty good about that. It only took 2 tries. Let's move over to the Visual Studio, and this is the actual code here. What's nice about this is I'm bringing in libraries from Wilderness Labs Meadow Foundation, just like anything else. Everyone who is a C# developer can write apps for Raspberry Pis, for a Meadow. You suddenly just all .NET people became embedded systems people, which is also going on my resume. You would not believe how amazing my LinkedIn looks right now. Machine learning and embedded systems, I mean, seriously, it's going to be, I'm looking forward that I'll be able to find a job. This is very readable code. I don't have to do any of the low-level stuff. And if I go and dig into the game, I'm using enums. I've got my result. When it's disconnected, right now the game just plays kind of randomly against itself. I could connect it to the cloud, talk Bluetooth. We've got sensors. Once you've got something in a tiny world like this, you can go and connect it to the intelligent edge and start doing really amazing stuff in the world. This is the Wilderness Labs Meadow Microcontroller. I'm going to be carrying that around, so if you see me or anyone else with one of these, you can say hi. And again, I got the screen from Adafruit, and I want to showcase our friends at Adafruit as well, because they have also put something very special together for us. Let's go back to the slides here. So this intersection between the intelligent edge and that intelligent cloud, let's switch back to our slides, thank you, has caused Microsoft's hardware partners to step up in a huge way, and there's an amazing number of devices. There are 10,000 partners in the ecosystem, and there are thousands of IoT solutions that are built with partners across Microsoft in a wide variety of industries. These are just some of these devices. There's probably a device that does the thing that you want it to do. We've partnered for this talk with Adafruit, and they are giving us a limited number of these Circuit Playground Xpress devices with the Ignite colors. These are fun because they have sensors, accelerometers, touchpads, speakers, IR transmitter, alligator clip friendly I/O. If you've never done anything on a tiny device, you can go and try it out with one of these. There is a limited number available. You just head over to the Development and Architecture Center out in the Expo Center. Just complete a challenge or talk to someone at the debug bar for help, and then pick up a device. Even better, if you don't have one of these devices or you're watching remotely, we've just announced that we have open sourced the Device Simulator Express extension that lets you run a virtual tiny device in Visual Studio Code. This is a really fun device because it can run Arduino, you can run Circuit Python, you can use our extension, you can use Visual Studio Code. It's very, very, very flexible. And now our simulator is open source as well. Super fun stuff. Thanks to our friends at Adafruit, and thanks to our friends at Wilderness Labs and their Meadow device. It is just a lovely time to be creating stuff with software at Microsoft. I hope that this session helps you understand a little bit of that broad set of options that Azure offers. As I always say, everyone is welcome. Any app, any language, any operating system, any tool, any application. You can learn more at azure.com/developer. And we have just this moment open sourced Rock, Paper, Scissors, Lizard, Spock. You can get that at aka.ms/rpsls. Big thanks, of course, to Sam Cass and for creating Rock, Paper, Scissors, Lizard, Spock. And also a big thanks to our friends, Mike Smith from Chipotle, Brian Cross from GitHub, Leslie Richardson, Seth Juarez, Jessica Dean, our demoers, and then also our friend backstage, Adrian Stevens, who helped me with that device. Microsoft appreciates you. Microsoft loves developers of all flavors, no matter what language you use. We appreciate you. And advertisement, watch Azure Friday. It's a really good show. I'm on it. Thank you, everybody. See you later. Yeah,